QueryLog streams represent an append-only record of database operations, captured in chronological order with microsecond-level precision. Each entry encodes the query text, execution context, resource consumption metrics, and temporal boundaries. Streams are organized by session identifier and persist to disk according to retention policies. The format supports both synchronous and asynchronous write modes, with configurable buffering strategies to minimize I/O overhead, while maintaining data integrity guarantees. The binary encoding layer uses a fixed-width header followed by variable-length payload segments. The header occupies 16 bytes and contains a magic number, format version, flags field, and total record length. Subsequent fields include a timestamp value stored as a 64-bit unsigned integer representing microseconds since epoch, a session identifier as a 32-bit hash, and a query type, enumeration occupying 4 bits of a shared byte with compression indicators. Query text is stored as UTF-8 encoded bytes preceded by a variable-length integer indicating the octet count. Queries exceeding 8 kilobytes in length are automatically truncated with a marker byte indicating truncation status. The payload section continues with a 4-byte field containing the query identifier assigned by the execution engine, followed by a 1-byte field indicating whether the query completed successfully or terminated in an error state. Execution context metadata occupies 24 bytes and encodes the requesting user identifier, database name, connection pool identifier, and transaction isolation level. The user identifier field contains a 32-bit hash of the authenticated username. Database and connection identifiers are similarly hashed to maintain consistent size across varying name lengths. The isolation level uses 3 bits to represent read uncommitted, read committed, repeatable read, or serializable isolation modes. Resource consumption metrics follow and comprise 8 32-bit unsigned integer fields tracking CPU cycles consumed, memory pages allocated, disk I/O operations issued, lock weights encountered, row count scanned, row count returned, index entries accessed, and temporary table pages created. These values are accumulated during query execution and written upon completion or cancellation. Overflow conditions are handled by clamping values to the maximum representable 32-bit quantity with an overflow flag set in the status byte. Temporal boundaries for each query record include 4 64-bit timestamp fields representing the moment the query was submitted to the queue, the moment execution began, the moment execution ended, and the moment the record was flushed to persistent storage. These values enable calculation of queuing latency, execution duration, and I/O write latency. All timestamps use microsecond precision relative to the Unix epoch with adjustment for system clock drift performed during stream initialization. Stream files are organized in rolling segments based on time windows and file size constraints. Each segment corresponds to a 1-hour interval and is automatically rotated at the hour boundary. Segments exceeding 256 megabytes in size trigger immediate rotation regardless of time window. Segment names follow the pattern QueryLog YMMDDHHMMSSUID with a ... extension indicating incomplete writes. Upon successful closure, the extension becomes .log indicating a sealed segment. The synchronous write mode applies a full fsync operation after each record is written and before the write call returns to the application. This mode ensures that a successful write return guarantees the record resides on non-volatile storage. The latency penalty is significant, typically adding 1 to 5 milliseconds per operation depending on storage device characteristics. This mode is recommended for compliance scenarios where audit trail completeness is mandatory. The asynchronous write mode buffers records in memory and issues periodic batch flush operations to disk. The buffer maintains a configurable capacity between 1 and 64 megabytes with a default of 8 megabytes. Flush operations are triggered when the buffer reaches capacity, after a configurable timeout between 1 and 30 seconds, or when the application explicitly invokes a flush request. This mode reduces write latency to sub-millisecond timescales at the cost of potential data loss on abnormal termination. Retention policies govern the life cycle of closed stream segments. The retention system supports time-based deletion, storage quota-based deletion, and record count-based deletion. Time-based retention maintains all segments created within a configurable window defaulting to 30 days. Storage quota retention deletes oldest segments when total directory size exceeds a configured threshold defaulting to 10 gigabytes. Record count retention deletes oldest segments when total record count exceeds a configured threshold defaulting to 1 billion records. Compression is applied to closed stream segments using either no compression, deflate compression, or ZST decompression selected at configuration time. Compression is never applied to open segments to avoid recompression overhead during continued writes. Compressed segments are marked with a compression type indicator in a metadata file alongside the sealed segment. Decompression occurs transparently during stream reading operations with decompressed data materialize into temporary buffers. Query filtering during stream reading uses predicate pushdown to minimize memory consumption and I/O. Filters on timestamp ranges, session identifier, query type, and execution status are evaluated against segment metadata before decompression and materialization. Predicates are specified as a conjunction of conditions with support for temporal ranges, set membership, and numeric comparisons. Filter evaluation occurs in a separate thread pool to prevent blocking the reading thread. Error handling during stream writes follows a configurable escalation strategy. Write failures are initially logged to the system error log without raising an exception. Consecutive write failures exceeding a configurable threshold default of 10 result in the stream entering a degraded mode where future writes are rejected and the application receives an explicit error notification. The stream remains in degraded mode until explicitly reset by the application after verifying that the underlying cause has been resolved. Stream integrity is maintained through checksum validation at multiple levels. Each record includes a 32-bit CRC32 value covering the record content. Each segment includes a footer containing a SHA-256 digest of all records in the segment. On initialization, the stream reader validates checksums for the current segment and attempts recovery by rewinding to the last valid record boundary. Corruption in sealed segments triggers an alert and prevents further reading of that segment. Stream initialization requires specification of the target directory path, which must exist and be writable by the process user. Directory permissions are validated at startup and cached for the duration of the process. The stream creates a hidden metadata directory named .QueryLog metadata containing configuration state, segment indices, and recovery information. This metadata directory must be preserved to maintain stream continuity across process restarts. Stream lifecycle termination requires explicit invocation of the close operation to ensure all buffered records are flushed and segment metadata is properly written. Calling close on an already closed stream is idempotent and returns without raising an exception. Resources including memory buffers, file handles, and background threads are released during close. Subsequent operations on a closed stream raise an exception indicating the stream is not in a valid state for operations.